Good afternoon, everyone. Before I can start, I would like to acknowledge my PhD students, Ravindra Sarvesh, Deepak, and Pavan. I think some of them are sitting in this room. So the title of this talk is Mapping the Himalayan Cryosphere. And this is sort of a highlight talk. I mean, we do a lot of observation in the Indian Himalayas and also high mountain Asia using remote sensing, and also we do some field work. But here I would like to show how we tackle old problems using new solutions using remote sensing, because we live in an era, we have a lot of data, and we have to really solve these old problems for larger good. So here we mimic a typical Himalayan glacier valley, as you can see here. There are various elements: atmosphere, cryosphere, which means glacial lakes, glaciers, snow, permafrost, and also hydrosphere. We have lakes, drainage, also groundwater, and of course impact on the society. So it is not, I mean, these different players work, and also they have interactions between each other in a typical Himalayan glacier valley. And I would also like to emphasize, and I'll come later, what also Rupam said, that we need more localized approach and knowledge. And I would try to make a case for this as well, based on our own experience. So this is a like Indo-European project which is going to start in 3 months. So this is the valley we have already started our field work. We are actually creating a super test site at least for 5 years, and we are going to do all the observation of aerosols, snow depth, glacial lake area volume, also going to track glaciers, discharge measurements, and of course we live with the local people, so we are also going to talk to them as well. But here, I would rather focus on glacial lakes, and we are driven by two simple questions. Are glacial lakes in high Asia increasing in numbers? And also, are glacial lakes increasing in size due to glacial retreat? I mean, these are simple questions, and also obvious in under climate change. But let's see, how we tackle them. So, what we have developed an automatic algorithm. Of course, it has been developed by Ravindra. And we live in an era, we have satellite data available in visible range, in thermal range, and also microwave remote sensing. And every sensing technique actually offers something, but it has its own disadvantages. So in simple, as I mentioned, this is a highlight talk. So we are actually going to harness all the data, like you, as on the left you see all the radar data that we stack together, because radar waves give you specular reflection, so all the water bodies look darker, as you can see here, while optical images in the visible are the real world images where we can see, okay, these are glacial lakes and glaciers and so on. But when you have a cloud cover, I mean, you cannot access the data and so on. Also, thermal remote sensing becomes quite important as well, because water bodies associated with glacial lakes, they had different surface temperatures. So we are going to use this information and see whether we can apply this automatic algorithm in entire high mountain Asia. I mean, that was the approach. So people at the moment, what they are doing is basically they're applying some water indexing based on satellite remote sensing data and apply any thresholding. But we all know that thresholding is not going to work holistically. It cannot be applied universally. So in this automatic algorithm, we actually try to address that problem and see whether we can develop an algorithm which can be universally applied and also threshold independent. And this is what we have done. So we detected 31,698 glacial lakes in high Asia in 2022. So this is a huge number. And in this map, we show the database in a way that split the entire high mountain Asia in 1 degree by 1 degree grid. And for your reference, larger the circle means more lake area, and the color scale also denotes number of lakes. So for instance, when we talk about Eastern Himalaya, the lakes are bigger, and also the number of lakes are more. For instance, this region, there are these lakes are basically very few in numbers, but they are big lakes. So this is the kind of database that we create. So as I mentioned, it is an automatic algorithm. So we applied not only in 2022, but also in 2016. So because we want to change how they're evolving in the last 5 years. Why 2016 and not 2000? Because in 2000, we did not have an access to all sort of optical, thermal, and micro remote sensing data, which is open source. So right after 2014, we have this, I would say, luxury of accessing all the data set. And so we can develop decadal studies and so on. So like we had an access of 6 years of of data set. That is how I show whether the glacial lakes are shrinking, stable, and expanding. It's obvious, most of the regions we find that either they are stable or they are expanding, of course. But this is 1 degree by 1 degree map, also indicating that lakes in the central and the eastern Himalaya are actually expanding. And of course, we hear once in a while that, okay, these lakes are, going through glacial lake outburst flood and so on. I'll give more examples on that. So this is the capability of our algorithm, which can be applied universally, and we can also find that, okay, what are the changes as far as the glacial lakes are concerned. But of course, needless to mention that we also do accuracy assessment using very high resolution planet data, and as shown in the presentation, that for all the larger lakes, where accuracy is almost perfect, I would say. And for smaller lakes, the accuracy is reasonable, more than 90%. And of course, we cannot do it for all the 32,000 lakes. It doesn't make sense. But of course, a randomly selected area, we found some high resolution images, and we compared our automatically derived glacial lake boundaries with this manually created boundaries. There are some existing studies also by Wolfgang. In 2022, you published a paper. And so we also randomly selected one area, which is around 6,400 square kilometers. And we found that, okay, we found almost 380 glacial lakes in 2022. Recently published by Wang is also 366. So in terms of detection and area accuracy, we are doing reasonably good. And of course, the algorithm works very well in terms of reputation and accuracy. Of course, if you have more questions, I can answer afterwards, but this is like sort of highlight. But this is like glacial lake area and how they change. But of course, they change in terms of depth and volume as well. As you know, we cannot just go to all 32,000 lakes, glacial lakes all the time. So, and also bathymetry in high altitude areas are always tricky. So what we have come across, there's a NASA's satellite altimetry mission, which we knew that in Greenland we tried, and it can penetrate into water bodies up to 25 meters. Of course, Himalayan glacial lakes are very turbid, and it cannot penetrate, so we tried. So what we tried, as you can see, the footprints passing over a glacial lake in the Himalaya. So most of these green photons are reflected from the surface, more than 80%. But we do find some of these photons are reflecting within the surface. So we applied something, and then we found a bottom topography of this glacial lake. And we know that we have an access to satellite remote sensing data as well, which give you information in the pixel. So what we did in this case, we actually tried to develop a model based on the reflectance in a particular band. On the x-axis, what you see, and the y-axis, the depth of lake we got from this ISET2. And once we have this function, we have this relationship, which is also very well known in the polar region. We are trying for the first time in high mountain Asia. We found that, okay, we are able to actually get the glacial depth and volume of this lake. In one of the Himalayan glacial lakes, we have some in situ observation as well. And we tried, just applied our model based on this, and then apply and see whether this makes sense or not. So yes, it is feasible to use satellite-based altimetry and optical remote sensing to find the depth in Himalayan glacial lakes. But at the same time, it cannot go beyond 5 to 7 meters. I would say it's some success, but of course, some limitation. So what we are doing right now is basically applying this model where we find shallow lakes, because we don't have any other option. We cannot go to the field for all 32,000 glacial lakes. We have lake area volume scaling methods, which we know cannot be universally applied and can always change. So we have documented 19 glacial lake volume relationships published for high mountain Asia, and they might not work. We also know that. So we are just finding and tackle this old problem with a new data set. This is what we are trying here. I would also like to mention the GLOF event, which I think you covered, or maybe we have been talking about this, South Lona Glacial Lake in 2023. What happened is, because this is a glacier, we have a proglacial lake. This is a lake outlet. So this lake has been expanding, as we all know. So what happened in a period of like few minutes or a few hours, this moraine collapsed, what we infer is because of the retreating glacier, it cannot provide any buttressing effect, and this moraine collapsed, as you can see here, and that actually triggered the glacial lake outburst flood, and which took hundreds of lives and infrastructure damages and so on. This is quite obvious now why this is happening. So what we have done, we are using microwave remote sensing, which we know that, using some repeat pass images, we can detect any centimeter level of deformation. So what we did is basically for South Lona Glacier, we applied more than 35 images, and we applied SAR interferometry technique, and we found that, okay, this is a stable, unstable region, which already was detected almost 6 months to 1 year before. So there's a slow movement of the moraine that we can capture using microwave remote sensing, which can inform people that, okay, these are any potential unstable areas around the glacial lake. And this is what we found. As you can see, I think you should focus on point B, which is this. This is approximately 2.2 centimeter of level of deformation over a period of 1.5 years. So this we can capture. All the green areas is relatively stable. So this we can identify the more instability and so on. So, and this is still not taken into account. So we are working on a project, so we want to do that for all the glacial lakes because it is also based on open source data. This is also where I would like to reiterate what Rupam said, that we need more and more local studies. Why? Because like this regional and the global and universal studies are important and they look really, really good. But at the same time, when we visited this Himalayan valley, what we found, this glacial lake has been expanding, as you can see here. In the last 3 decades, it expanded 25 times. It is now storing 5 billion liter of water, which nobody's talking about. It is not even in the database of high risk, nowhere. When we just talked to local people, we also camped here. We also found one interesting aspect, that this pass, what red line you see, has been used by many invading armies and shepherds, trekkers for the last 300 years, also documented by British and people across the globe. We met a lot of them also, and we asked, what are you going to do? Because I can see this lake is going to expand in 3 years, and this pass will go forever. And there's no other pass. And we talk to them, and they say, no, it cannot happen. This is the way of life, and this is going to remain. And that is, I'm not a human scientist and so on, but we talk to people because we cook together, we eat our food together. They help us, and this is what we say. This story should be told, and that's why we wrote an article which was published in the leading Indian newspaper. And what we are doing right now, also highlighting this aspect, this glacial lake is not in the database. This pass nobody's talking about. Actually, we put the title, A Dying Himalayan Passage, and we found all the evidence based on our observation. And I also emphasize that we should really do some local studies as well. Every Himalayan valley should be dealt with scientists, with including all the aspects. It is very, very tricky, but it is worth doing. And now I have shared this article with so many people. We are working with the army, local people, which are also not aware, authorities, to actually create a new pass and an alternative, also at least inform them. So on this note, so we are actually also setting up 3 time-lapse camera system, probably for the first time, above 4,000 meter above sea level, to monitor these Himalayan valleys around the year. So on this note, I would like to thank all of you. Thank you so much.